So first of all, thanks a lot, everyone, for joining. I'm really excited to be at this event. Personally, I've been passionate about maps since I was, I think, 6 when I got my first globe, a bit like the one next to me here. And yeah, I was hooked for life. I've been working with geospatial maps for 22 years now, and at Transport for London, Ordnance Survey, TomTom, and now product management at Here Technologies. So I really do live and breathe maps and geospatial technology, so really excited to be here. We've seen an amazing transformation over the past 50 years or so, digitizing the planet, the geography that we have on the planet. And we've done an outstanding job. That's great. Almost every corner of the world now has been mapped digitally, and we all have incredible gadgets in our pockets that show us that power of geospatial location. But there's still room for improvement. For example, of course, HD maps will help us to realize a truly autonomous world, which will allow for more safe, more efficient applications and make everything better connected together with self-driving cars, robots in factories being automated, deliveries getting automated. Clearly, there's a lot of room for improvement still. That's clear. Also, another area of improvement, mapping experiences. They generally today are, of course, very impressive, but they still, in many cases, need to solve that truly seamless experience where the navigation starts from your home and takes you all the way to your final destination. That may be deep inside of a building, because we as human beings, of course, spend a lot of our time indoors. So it could be a gate at an airport or a train station platform, perhaps an office meeting room. That's what I mean by seamless connectivity. Whereas today, most navigation systems tell you you have reached your destination when you're in the middle of the road. That's clearly not your destination, right? You're going somewhere else beyond that. So there's room for improvement. Clearly, in order to get that really right, you need a lot of different additional geospatial data. And I'm talking there not just about outdoor maps that, as I said, we've done a tremendous job already over the past half a century mapping the world digitally outdoors. I'm also talking about indoor maps. I'm talking also about seamlessly connected experiences through those buildings, and not just standard indoor buildings, also transit hubs, parking garages, bringing in then the electric vehicle stations that are increasingly going to be needed in the world that we are now moving towards, allowing for micro-mobility to connect through these hubs and make everything better connected. And that's really a problem that we all still face. Train stations, airports, offices where we may well be heading, stadium seating. There's clearly many different use cases, hospitals, many different buildings that we all spend our time in. So offering that kind of truly end-to-end seamless navigation, that's a problem that we still face. And that's the problem that I want to focus on in today's talk, where we're talking about really solving that last meter. So let's get started. So first of all, how many of us have got lost in an airport? Airports being typically a place where time is limited. They're quite confusing. So for that reason, according to CPP research, 41% of passengers struggle to find their way around foreign airports. 20% have had to run to the gate. And 14% of us have missed flights due to avoidable bottlenecks. And in fact, that number goes up to 28% in the case of millennials. So there's clearly a big problem also to be solved at airports. Then if we look at another use case, hospitals. 7 million missed appointments per year at hospitals in the UK alone, 7 million, and most resulting from navigation problems, according to the UK's newspaper, The Guardian. In the United States, the Wall Street Journal writes, visitors struggle to navigate the maze of the modern medical complex. And then also within those hospitals, the staff themselves are struggling, where you have, on average, 1 hour per shift being spent by nurses searching for equipment. And that's equipment that may well be right next to them, but they can't see it because there's a wall in between. And if that wall weren't there, they could see it immediately. That's where navigation devices, tracking services such as here tracking and others can really help to save time. The navigation can help to reduce those missed appointments, offer a more seamless, truly end-to-end navigation experience in hospitals. Then if we look at one of my personal favorites, an area that's really quite difficult to solve, which is why it's fun. 30% of urban traffic caused by searching for parking. So 1 in 3 of the cars that you're seeing in inner city areas is someone searching for parking. That's clearly not a very good position to be in. And 63% of us avoid destinations due to parking challenges, which really can impact, particularly in inner city areas, the success of local businesses. The overall DNA of the city starts to transform itself. And we've been struggling with this for a while. So these are clearly problems that we all face today. And when we look at the number of hours that we're spending, for example, searching for parking, according to INRIX, 17 hours per driver per year are spent searching for parking on average. And in big cities such as New York, it can be even above 100 hours per person per year. So that's, again, a very inefficient way to use our time. So now let's look at what we can do about that and how we can really solve these problems. So at Here Technologies, we've been looking at ways to solve this by introducing seamless routing that combines the outdoor and the indoor location services that we've been building for around 10 years now. Routing via, for example, nearby parking spaces, even inside of complex parking garages, where you may have EV stations, micro-mobility zones, electric scooters, for example. You might want to park in an electric vehicle station right next to a micro-mobility zone to pick up your electric scooter and then continue on your journey. Attributes for indoor ADAS, advanced driver assistance systems, inside the parking garage to optimize the way the vehicle behaves inside the garage, increase safety, increase situational awareness as you move around the garage. And then ultimately autonomous valet parking, where the car, you drop it off outside the garage, you go and do your shopping or take your flight. And then when you come back, you retrieve your car from the zone. Even the car parks itself, can charge itself, can go to the car wash on its own. This is the type of autonomous valet parking services that we are now enabling with the maps that we are building. And then routing to indoor points of interest, such as perhaps a retail store, let's say Starbucks, or a gate at the airport, or a conference room in an office. These are the types of points of interest that we as human beings typically want to get to. That's your destination on that particular leg of your journey. And then the connectivity between the floors with settings that enable and disable, for example, stairs, escalators. With an aging population, that's going to become increasingly important, of course. That all needs to be part of this truly last meter experience, which seamlessly connects from your home all the way to your final destination. Now, let's have a look at a couple of examples of the APIs and SDKs that we have in order to consume this combination of location services and mapping. For example, our Here Maps API for JavaScript and the Here SDK Navigate already today offer you the types of experiences that you're seeing here. This is a screenshot, by the way, from our developer.here.com webpage. You can see the link at the bottom here. This is something you can play with today. It happens to be an example here, but there are multiple different ways that you can play with this yourselves. Zurich Airport is a very nice one that you can play with, where in this case, we've planned a route from outside the building. You can see the route going along the street network. And then at one point you transition then into the indoor building, and the route continues inside the building across the multiple floors within that building to your final destination. And in order to show you how you can play with it, we also have some code snippets there that you can play with, you can manipulate. You can see here, for example, the origin with the coordinates, the destination with the coordinates, but also the ID of the building in question and the level ID, which is of course the floor. And then the transport mode, in this case, pedestrian, and potentially some avoid features, like avoid an elevator, for example, or avoid stairs. You can play with that as well, and the route will recalculate itself according to those settings. Then in terms of the data itself that underpins all of this, the Here Indoor map is a great example of what you can then, really get into the hyperlocal context then with these kind of maps. Building geometry, of course, the outer perimeter of the building, the inner walls, the whole location within the building mapped to a granular level of detail. The indoor points of interest could be a gate, could be a retailer inside the building. The connectivity between the floors that I mentioned before, the stairs, escalators, elevators, the entrances and exits that are the connectivity between the outdoor and the indoor world. And then we've got some tools that anyone can then use if they want to update their map. So let's say you're an airport operator or a parking operator, you can just go in and you can make those edits yourself in a nice and easy web browser tool. And those changes are then reflected immediately in the SDKs and APIs for your community of users to consume. Then we also have the option to keep the maps private, of course. That's by default what you get, a private indoor map. And then you can make that public if you want to, or you can share it with a certain audience that you define, or you can share it on our Here marketplace just as data, for example. So the data is available just for you to download. To get access to that raw data, it's a GeoJSON file. But you can also then use the SDKs on top, which is really where the value is, the SDKs that I mentioned before, so the Here SDK and the Maps API for JavaScript. And then if we look at the indoor parking maps, here's a nice example. You can see on the right side the type of detail that we include in those maps with the lane level geometry, the directionality, the entrances and exits, the barriers, and then the connectivity, of course, between the floors, not just including the pedestrian ones, but also the ramps, spiral ramps, as you can see at the bottom there, for getting between the floors as well. And then each parking space, of course, has its own geometry, but it also has its own attribution. In this case, you can see disabled bays. It could also be an electric vehicle station, and having that visibility also as you enter the garage to know where you want to park. Then you could bring in APIs for real-time availability as well to change the color of each of the geometry. Each of the objects inside of our maps can be programmatically changed for the rendering to different colors, typically green for available, red for not, or just whatever you want. That's the flexibility. And then in terms of other things that the maps contain, I mean, I'm always amazed at how much actually goes on in a parking garage. I mean, there are a lot of different POIs inside of these garages. Of course, the obvious ones like ticket machines, toilets, fire extinguishers. There can be car washes. You know, it's amazing that the richness that you find inside of parking garages. And when you get in there, you start to see them all, and you can map them and make sure that they're available. Then the micro mobility stations, the barriers to get in and out, it's endless. So making sure that that is really covered in the map. And let me show you a demo of just how that can then all fit together, which is something that we obviously want to make sure that the data seamlessly then fits with the SDKs, your position either from the vehicle, where you have dead reckoning and multiple different ways that the vehicle can know where it is, or then on the mobile phone, potentially with visual-based positioning and a number of other technologies that are out there for positioning of your phone as you move around the garage as a pedestrian. So let's take a quick look at one example that we've got here, which is one inside of a parking garage. You start off outside. This is the typical map view that you see. As you zoom in this case, you see a marker showing the availability inside of this parking garage. If you want to, you can then look inside of it. You can tap on it and then take a deep look inside at the different geometry inside of the garage, change the floors. You can zoom in to see different types of attributes, the family parking, the electric vehicle stations, the disabled parking, all being visible there as well. And then you select a space that's right for you, like searching for it, in this case, family parking, or it could be an electric vehicle station. Let's select one of those and plan a route to it. And what we'll do is we'll plan a route to it with a destination outside the building, because clearly that's also not your destination inside the parking garage, unless there's something really wrong with you. So let's plan it all the way then out as well. And here you can see the vehicular route in dark blue, and then the pedestrian route in light blue, with the parking space in the beginning there, in the middle of the screen. That's where you transition to pedestrian mode. And now let's look at what that would look like from a cockpit perspective. So with our SDK, you can also view it from cockpit view. And then when you turn in from the outdoor, you can then transition to the indoor map, down the ramp into the parking garage, and then turning in towards your parking space that you've selected with the electric vehicle station, park your car, plug it in, switch to pedestrian mode, and walk to your final destination, initially through the parking garage, but then heading out to a pedestrian exit that's clearly marked there on the map. And then as you get towards the exit, then you transition back out to the outdoor map again and through to your final destination. So that's one of my favorite ones there to show you, but there's plenty more. But in the interest of time, let me show you just one more now, which is also there intended to help the driver from the cockpit view inside of the car. We've been looking at different ways to help the driver to navigate the parking garages, which are typically very dark and confusing places. So what we've done here is we've been looking at ways to leverage first of all, the model of the building as you approach, to show you the different levels inside, the parking levels in this case, to get you a context, an overall context of the garage and the building above. And then we switch to this kind of augmented navigation by leveraging the screen size here. And as you drive in, transitioning into the AR mode, giving you then arrows that appear on the screen to show you where you should be going, giving you an overview of the garage, and then also additional information about pricing, or then about that specific parking garage, and then arrows all the way to your parking spot that you have selected. So that's one way that you can also render this to make it a little bit clearer to the driver how they then get to that parking space. So if you zoom out a little bit, you can also see other ways that you could potentially render those parking garages. I mentioned earlier the possibility within our SDKs to render individual geo objects depending on a status. So in this case, the parking availability, where we've put the parking spaces, we've marked them in green, so you can see the available ones. So you get that better context again within this confusing indoor structure called a parking garage, to make that just a little bit easier and help that last meter experience that we are trying to solve become just that little bit less confusing, and make sure that you really do reach your final destination in the most optimal way. Great, I'm conscious of time, so let me leave it at that. It's been a pleasure talking to you. Thank you very much. Do feel free to reach out to me directly. You can see my details there. And absolutely do go to developer.here.com to play with some of what Rajesh was showing earlier about the Here SDK, but also specifically do have a play with these indoor maps as well, and some of our new parking services there as well. So many thanks, and I'll now take some questions.